All right, thank you for the introduction. So how's everyone doing? Can you hear me clearly in the end? Great, thank you. My name is Yusei Nishiyama. Today I'm going to give a talk entitled Working at Scale. I tried to make my presentation as practical as possible, so things I'm going to talk about is something you can try out right after you go back to work. Before I get into my talk, I'm going to give you a little bit of background of me and my company so that you can better understand the context of the talk. Cookbot, a company I worked for, is the largest recipe-sharing service in the world of making everyday cooking fun. We cover 67 countries and support 21 languages and have 100 million of users all over the world. We have headquarters in UK and Japan and branch offices in Spain, Indonesia, Lebanon, and some other countries. In terms of iOS development, we have 10 iOS developers, 4 of them in UK, 4 in Japan, 1 in Lebanon, 1 in Colombia. Yeah, I might be wrong, but just want to mention the team is really distributed. So, working for the app, which supports a lot of users in distributed team, involves tons of challenges. So I'm going to show the challenges we have and how we were dealing with them in those two parts, working in a large team and working with large code base. Let's move on to the first topic, working in a large team. So if you work in a team, you may have issues that you never have when you work alone. So like someone blocks the build and the rest of the team don't know how to fix it properly. And maybe someone's vacation prevents the team from making a new release, which is terrible. And code review also can be a problem in a big team because assume you are submitting a pull request which has a lot of mistakes and syntax errors, and the 10 plus developers start reviewing your pull request at the same time, you're going to get massive feedback, and it takes ages to deal with all of them. Generally, you can deal with those things with continuous integration and automation, and none of those tasks should be developer dependent, and you shouldn't spend any time for what machine can do. So I'm going to show how we automate those things like testing and nitpicking, beta distribution, and release management. When you say CI, it should consist of several subsystems. So this is an overview of our CI system. The diagram starts from the point where a developer pushes his or her change to GitHub. Then GitHub triggers a Jenkins job through webhook. Jenkins executes a fastlane script, which is called lane in the context of fastlane. So I won't mention much about fastlane because we're going to have a talk from the author of fastlane later today. So we have 7 fastlanes, which have 20 lanes inside, and the total line number of the script is more than 700, which is obviously bigger than the typical starter example. Fastlane is now very popular among mobile devs, and you might have been familiar with most of common use cases like uploading a binary to Hockey app or running tests on CI. So I'm going to show lesser known and a bit more practical examples. Syncing dSYMs. If you enable bitcode, it's Apple's server who compiles your bitcode and generate dSYMs. So you need to download the generated dSYMs from upload server and then upload them to your crash reporting service, say Crashlytics, so that they can symbolize those crashes. So this script automates those processes. The next example is simpler than it looks. It logs into iTunes Connect and checks the status of a submitting version. And if the status is pending developer release, the script just releases the app automatically with posting comment on Slack. You, of course, can do it manually, but you might not want to see the bit clunky iTunes Connect on your browser. Our CI server also automatically builds the app and distributes it to testers for every push to GitHub. But there must be some cases you don't want to distribute it to testers, like updates of documentations. It's just a waste of CI resources. So we decided to distribute the beta version only if a pull request is labeled as beta distribution. Getting labels from GitHub is also very easy with fastlane. Fastlane has GitHub API with which you can call GitHub API very easily. As far as I remember, I think it's introduced recent fastlane update. And those lanes in this example just fetch all levels of specific pull request and check if it contains beta distribution level. With fastlane and GitHub API, you also can notify developers of new beta version by commenting on GitHub directly. So you're going to get something like that on your pull request when the upload finishes. The next part is Danger. With Danger, you can define rules that each pull request should meet in a text file, which is called Dangerfile. As we've already had a great talk about Danger and code review in general, so I don't dig down into the detail of Danger, but just want to mention you can run swift-lint against your your pull request through Danger. So this is how your pull request is going to look like with Danger. So you can save developers time of nitpicking, like, so yeah. So in a first example, so this line exceeds the line length limit, and it automatically so reviewed by the bot. The next part is where our system becomes a bit unique. We collect our code metrics in a database, which is called InfluxDB. InfluxDB is a data storage which specializes in time-based data, as it has built-in HTTP API and has a lot of client libraries in many languages. So it's very easy to integrate InfluxDB into your build process. And another thing I can mention is it's written in Go, so it's really fast and really responsive. For example, fastlane again. So we have fastlane script which measures test coverage here, then uploads the data to the database. Those data collected in InfluxDB is visualized and read through Grafana. Grafana is a metrics dashboard and editor. and supports InfluxDB as a data storage. So this is an actual change of our test coverage. The test coverage, to be honest, it's not great, just about 20% or so. But at least we can say we are getting better. I think that's why visualization is really important. If the data is accessible and visualized, so everyone can be aware of something good and bad happening in your team. We also utilize this InfluxDB and Grafana to measure every kind of metrics. We monitor the number of issues, number of pull requests, and also average lifetime of merged pull requests. So you can use those data to see how productive your team is and how stable your app is. For example, if the number of issues is getting larger, bigger constantly, it means it's something wrong happening in your team. So let's move on to the next part. So working with a large code base. So let me ask a question. How many times do you build every day? And more generally, how long do you usually wait for build every day? If it's just a simple personal project, it should be okay. But once your code base becomes big enough, you're going to get into trouble. In this part, so I'll show you, how to improve it. So in the two parts, measurement and improvement. So please don't worry, I will not talk about those nonsenses. So if I need to do something like that, I would use Objective-C or maybe either whatever. All right, first thing first, measurement. Needless to say, if you want to improve something, you should start from measuring and start from understanding the problem. I think referring Donald Knuth's saying is one of the best way to persuade your team to do something. So the first thing you can do is probably to enable show build operation duration flag. It displays build time on your Xcode so that you can always be aware of your build time. But it's not enough since build time process can be broken down into, for example, resolving dependencies and compilation of each source file and running a test. So you need to know how long each process takes to understand the bottleneck of the process. Fastlane does a great job here as well. Fastlane generates a report as an XML file with which you can get a good insight of how long each process takes. This is just a JUnit style XML file, so Jenkins can render the result as a test result. So in a Jenkins console, you can check which lines were executed and how long they took and whether they are successful or not. Ordering by duration, you can see where the bottleneck. For example, in this example, it says it took 5 minutes to archive and 2 minutes to test. So if I need to improve the total time of build process, I would start from those two parts. So now we know how long each process takes. but you still can break down compile phase into the compilation of each function. So an easy way to find a function which takes a long time to compile is to enable one long function bodies flag. If you turn the flag on, Xcode warns you of heavy functions. In this example, I set threshold 100 milliseconds, and Xcode complains because the function here took 15 seconds to compile. You also be able to let the compiler print out how long each function takes to compile with debug time function bodies flag. You can play with those data just by copying and paste it in your terminal. But those data, those build log are also available under dylib data, which we developers have removed hundreds of times. Anyways, the extension of the build log is xcactivitylog. But it actually is just a gzip file, so you can unzip it and read it as a plain text. So let me show an example of how to utilize the data. With the build log, so one of my colleagues developed a Danger plugin, which comments directly on a function which took too long to compile. So it gives us more chance to consider if there's any other way to write the same function in a bit more compiler-friendly way. The next part is about how to improve it. In this section, I'll show you how much my idea worked with the real data from the real application. The project consists of 40,000 lines of Swift code and uses CocoaPod as dependency manager, and which has 38 direct dependencies and ends up installing 60 libraries. The green dot here indicates that it took 48 minutes to archive and test on CI. So that's really bad. So we should do something for it. The easiest but most effective technique is to use whole module optimization. With whole module optimization, Swift compiler compiles all files in a module at once. The intended benefit of whole module optimization is to let the compiler optimize code more aggressively, but there's a bit hacky technique with which you can tell the compiler to compile all files in a module at once, but without any optimization. You can try this out by setting optimization level whole module optimization and specifying none in other Swift flag setting. To be honest, whole module optimization without any optimization doesn't really make sense, but it makes the build really fast for most of the cases. So now with this setting, CI takes less than 20 minutes to test and archive. Before I try more ideas, I'd like to get more detailed information by enabling debug time function bodies, which I explained in a previous slide. Compilation time is also collected in InfluxDB and visualized in Grafana. So through those data, I found some libraries called this slow build. And you can see the first two time-consuming functions from Rx Swift. So I decided to manage those huge Swift libraries with Carthage instead of CocoaPods. So with Carthage, Xcode doesn't need to compile those frameworks every time you run the application, because Carthage prebuilds those frameworks. So one thing you need to take care is API stability again. So as Swift API is not stable yet, so all of your prebuilt frameworks must be built with the same version of Swift compiler. However, this is not going to be a problem anymore, because API stability is one of the primary goals of Swift 5.0. Carthage saves 10 more minutes, so it finally improves the build time by 85%. So yeah, it's great improvement. By the way, Xcode 9 introduces a new build system. It's written in Swift and promised to be more performant than the old one. So it's kind of opt-in. So if you want to use it, you need to explicitly change the build system to new build system. So I compiled the project with Swift 3.2 and Xcode 9 new build system, but unfortunately, at least for our case, I can't see any significant improvements on build time. Maybe because the new build system is still preview version, maybe. Though I've already saw a great improvement in build time, but it still takes considerable amount of time. So here, one question came to my mind is, so do I really need to build the entire app every time? The answer should be no. So you can separate your app into multiple components so that you don't need to compile the entire application every time, because a change you make to a module doesn't trigger rebuild of any other modules. So it improves incremental build time dramatically. The benefit of code modularization is more than faster build time. You also can get stricter access control. As the default access level of Swift is internal, so everything you put into your framework is private from other frameworks. So it gives you more chance to consider which properties and methods should be private or public. It's also nice that boundaries between frameworks are really clear. You could build function-based theme just by assigning right people to each module. So those are lessons learned. So if your app is huge monolithic application, to be honest, it's not an easy job. For our case, our API client is tightly coupled with session management layer, and breaking this dependency is really tough. And after some consideration, so you decided to do this, breaking your application into multiple components, then you should start from a single repository instead of having multiple repositories for each framework. Because at the beginning of the process, your framework must not be very stable, and moving back and forth between multiple repositories while developing them is kind of painful and slows you down. Then after a while, you will get a point where your framework is stable and not changed very often. Then you can consider separating them into different repositories and use pre-built versions of them. But there's a pitfall of code modularization, it's dynamic framework loading time. You can check how long dynamic library loading takes by enabling dYLD print statistics flag. If an app takes very long time to open, the system kills your app. So I had some people work around the issue by merging all frameworks into a single framework, then link it to the main application. But I think it's not a simple solution. So dynamic library loading times was my only concern for moving my idea forward. And it seems not to be very encouraged by Apple itself. I was still in two minds about whether I should encourage this idea to everybody or not. But this concern has been gone because now Xcode 9, specifically Xcode 9 Beta 4, starts supporting Swift static library, which is great. So now I'm pretty sure this is a way to go. So this is the end of the talk. So let me recap. To automate your daily workflow, and Danger reduces your workload of code review and visualize everything you want to improve. And revising your project settings may improve your build time dramatically. And code modularization also improves build and index time and helps you get better structure and better structured code and themes. So I need to bit hurry to finish my talk, but don't worry, my presentation is available here. Yeah, please take a picture. Oh, sorry. I have one more slide.
Thank you.
Thank you.
Thank you.
Oh, microphone. Keep the mic. Yes, sure. Awesome. It's a bit hard to talk about CookPad right before the lunch. Sorry for that.
Yeah, people are starving, I guess.
Yeah. I've been really impressed by the improvement that you achieved on the build time reduction. I wasn't aware that we could achieve such huge results. But looking at that, I was thinking why the metrics of the build time is not more accessible in Xcode. I mean, shouldn't be?
Yeah, it should be. Yeah, I think if they have, I think it's really helpful.
Yeah, because you just have the global build time, but we would need more like what you just saw. It would be nice to.
But we have a lot of custom workflows with fastlane and Danger. So I think it's it's very hard to know those process how long those process took. So yeah, we still need to do something to know. Yeah.
Because with your workflow, you need to push all that code before having the information, right?
Yes.
So that's a bit tricky.
Another problem in scaling is not only the growth of your code base, but also the growth of your team, often. What's your experience with CookPad? I mean, how did the growth of your team influence your daily productivity? Do you have how did that change for example, for code reviews?
So for code reviews, I think every team has the same kind of problem, which is people can't spend enough time to code review, and someone at some point claims we should spend more time for code review. But how can we know how we are bad now, and how we can tell how we are good enough? So one possible solution is just rely on your gut feeling. I mean, if you were thinking you were good, you're good. That's it. But we're developers. There must be a more reliable way to know that. So that's why we measured average time of lifetime of merge pull request, so that we can say now we have this number X, and this should be Y, and yeah.
And do you have that for the code review time, for example?
Yes. So yes, we have.
You have a Grafana with a
yes.
dashboard saying,
yeah.
wow, that's really nice.
So For example, now the number is kind of 4 or 5. So we recently have a bit complex and a big pull request. So we think this should be 3 or 2.5 or something.
And is that a rate or is that a number of hours? Like
A number of days.
Days.
Yeah.
Wow, days. Oh,
So
that's a lot.
You're a Grafana-based company.
Yeah.
Yeah, that's really interesting. This usage of Grafana. Usually, Grafana is more used in to do production supervision and showing metrics on production. But using it to display some build time or development metrics, and having that tool allow you to actually see those metrics. And if you just have metrics and you don't look at the metric, it will not improve. But as you were saying, having those metrics will force people to try to work on that. What have you been seeing in terms of improvement with that?
So, for example...
For example, on I don't know, code review time, you said it was improved a lot, the code review time, just by having it displayed, or other metrics that you would display?
Yeah, for example...
Or build time
Yeah,
reduction.
at some point, someone added a new script, new fastlane script to automate some process. And after then, we see a spike in the graph so that we can realize we actually had this experience. So there's something wrong in the script. So we can improve this, or we shouldn't do that.
And you know that very quickly. Like, you don't have to wait that things are getting really bad before you have to optimize things.
Yeah,
That's really
yes.
interesting.
And so that's more a curiosity, actually. What's your build stack? Do you use build on the cloud or just locally?
So, I mean, we use Jenkins.
Okay,
Yeah.
Jenkins, okay.
And it's like self-hosted on your machines? Or?
Yeah, luckily we have enough resources to manage those CI things, so we just want to fully control over it. So that's a reason why we use Jenkins on self-hosting machine.
All right.
Thank you very much for this talk. Really
Thank you.
Thank you. My pleasure.